Hello and welcome back to the System Design series, where we are discussing all the important concepts for high-level system design interviews. Today we will be designing a unique ID generator. Before designing unique ID generator, let's first understand why do we need unique ID generator in a software system. Unique ID generator is a very critical component in a number of software systems. We can think of any domain, we need unique ID generator. If we are thinking about e-commerce, order ID, product ID, etc. needs unique identifier. Hence, for these, we need unique ID generator. Similarly, for banking, we have transaction ID. For social media, we uniquely identify comments using comment ID. Similarly, we can have post ID as well to uniquely identify the post. Even in log management, we attach unique key for log event for easy retrieval. Hence, unique key generator is a component which is being used across the domains. Today, in this session, we will be designing a resilient and scalable unique ID generator. Before start designing the system, let's first understand the requirements by asking few questions. We need requirement clarification. During this phase, we will ask few relevant questions and get it answered so that we will have better understanding about the system we are trying to design. Questions will be something like, is this ID alphanumeric or a numeric one? Should we generate fixed length ID? Will it be a random ID or a sortable one? Sortable means the IDs can be sorted in ascending order or in descending order based on when they have created. Apart from this, we also have to understand the scale of the system we are trying to design. Hence, the question, what is the DAU of the system, will be a relevant question. We also need to know what will be the size of each ID. Why requirement clarification is important? Based on the answer to these questions, we will be able to refine our requirement. Hence, we will be able to design a unique ID generator which will be best fit for our requirement. Let's assume for our design, we need a numeric ID. We want a fixed length ID. Wanted to have a sortable ID for our system. Let's assume the DAU is 100 million and each user will be generating 10 keys on an average. Let's assume we want a 64-bit fixed length unique ID. So this will be, or it will be 8 bytes of unique ID. Once we have clarified the requirement of the system, it's important to perform back of the envelope estimation to understand the scale of the system we are going to design. If you are not aware about back of the envelope estimation, I have a complete video on this and the video is there in the same system design series. Do not forget to watch it out. We have 100 million users per day and each user is creating 10 keys per day. So total number of keys will be generated by the system is 100 million into 10, which is nothing but 1 billion or 10 to the power 9 keys per day. What will be the QPS of the system? QPS is also known as queries per second. 10 to the power 9 keys will be generated in a day. So this many keys per second will be generated by your system. 10 to the power 4 or 10k requests per second will be executed in our system. In other words, in every second, we have to generate 10k unique IDs. Let's understand about the storage requirement for the system. We generate 10 to the power 9 keys and each key is of 8 byte. So per day, we need 8 GB of data to be stored in our system. If we want to keep the unique IDs in our server, there could be another case where we will not be storing any unique IDs we are generating in our system. In such cases, we do not need this much storage requirement. It depends on the use case you are solving with the help of this unique ID generator. Both requirement clarification and back of the envelope estimation are very critical steps for designing any software system, because from requirement clarification we can understand about the specific use case where our system will be used. From back of the envelope estimation we will clearly understand the scale of the system, and both of these are important parameter to influence the design of our system. Hence, in each and every system design interview, you have to clarify the requirements and estimate the back of the envelope estimation so that you will get clear picture about the system you are going to design. Let's start with our initial design. We will start with very simple approach with a single server, and we will be refining our design as and when we encounter some or the other issues. In a single server approach, we will have user who will send us a request to get a unique ID. ID generator server will receive this request and can perform a very simple operation. Something like we'll have a counter which will have initial value as 1. It will return the counter value to the user as initial unique ID and then increase the counter value. This is a very simple approach and can work if we have very less number of requests which are coming from our user. Let's understand what are the issues with this very simple single server approach. It's a single point of failure. If we see from our requirement, we want fixed length ID. However, based on this approach, we cannot have fixed length ID. Though the IDs will be sortable in nature, which is required for our requirement. It is good for the system which has less load, but if you see from the back of the envelope estimation, we want to generate 10k unique keys per second. Our single server approach will not be feasible for the load. Hence, we will not be able to use this single server approach in our specific use case. Next, natural choice is multi-server approach, where we will have user which sends get unique ID request to a load balancer. Load balancer distributes the request among multiple servers. All these servers generate unique IDs and return it back to the user. By introducing multiple server, we can solve this single point of failure. As we have multiple servers, it can handle larger load. Let's understand how can we generate unique IDs using these three servers. We cannot have the same initial value of each and every counters. If we set counter as 1 to all the servers, then we will not be able to generate unique IDs from this system, because there will be multiple requests coming from user. It will go to any of these three servers and it will return the initial value as 1. Hence, there could be multiple get unique ID requests where our system will send duplicate ID. Hope you have realized the issue. So we can solve something like this. For the first server, let's assume counter is 1. We send unique ID as 1 and then we increase counter plus equal to 3 as we have 3 different servers. So from server 1, the first request will get unique ID 1, second request will get unique ID 4, next one is 7 and so on. For second server, initial value of counter will be 2. For third server, initial value of counter will be 3. Counter will increase as counter plus 3. So the first server will generate unique keys something like 1, 4, 7 and so on. Second server will generate 2, 5, 8 and so on. Third server will generate 3, 6, 9 and so on. In that way, intelligently we can set the initial counter value and the increment of the counter value such a way that any request is going to any server will always return a unique ID. Hope you have realized this simple idea. What is the issue in this system? Though this system is not a single point of failure anymore, even if server 2 is going down, our system will still generate unique IDs for each and every request. It can handle large load as well because we have multiple servers in place. However, the IDs will not be of fixed length. As per the request, we need fixed length ID. Hence, we will not be able to use this multi-server approach. Let's see some other approaches which are being used in the industry. UUID approach. UUID is 128-bit ID. Hence, it is helping us to create fixed length ID, and UUID is always be unique. As per the research, if we generate 1 billion IDs per second, then it will take 100 years to appear such a situation where there is a chance of duplicate UUIDs is of 50%. Hence, we can assume that in real world system, we can safely use UUID to generate unique IDs. However, UUIDs are random in nature, but we do not want random ID, we want sortable ID. See how requirement clarifications are very important to choose the approach of your design. UUID is alphanumeric. Because of these two reasons, we will not be able to use UUID approach in our use case. However, if you get some requirement where random IDs will be sufficient and the ID can be alphanumeric, then we can safely use UUID approach. Apart from these approaches, we also have something called ticket server approach. In ticket server, we will have user which will send the request to a load balancer. Load balancer will send the request to a number of servers, server 1, server 2, server 3. These servers will not generate unique IDs. Rather, it will ask to another server called ticket server to get the unique fixed length ID, and eventually it returns to the user. But this also will not be suitable for our use case because this will have similar issues as single server approach. We can have another approach called Twitter Snowflake approach. Let's understand what is it. In this approach, let's assume we have a bit stream of 64 bits starting from 0 to 63. We will split this bit stream into multiple sections. In first section, we will add timestamp value. In the second section, we will be setting the bits to represent server ID, and the third section will be for sequence number. So the entire 64 bits will be splitted into 3 different sections. First section will represent the timestamp in milliseconds. Second section will represent the server ID, and the third section will be responsible to represent sequence number. This approach is known as Twitter Snowflake approach. Let's understand the benefit of this approach and how this approach is well suited for our use case. IDs are of fixed length. The IDs will be sortable. ID will be numeric in nature. So if you see, Twitter Snowflake approach is in line with our requirements as well. Hence, this is the best approach what we can use in our design. We can even extend this Twitter Snowflake approach one step further, where we split all 64 bits into 4 different parts. First one is timestamp. Second part will be data center ID. Third part will be server ID. Fourth part will be sequence number. The benefit here is we are now changing our system to a multi-data center system. What is the benefit? It enhances the reliability of the system. Let's assume if we keep all the servers into a single data center and the data center goes down because of any reasons like power failure or natural calamities, our system will stop working. But in this extended approach where we are spreading our servers among multiple data centers so that even if one data center is going down, we can still generate unique IDs based on the requests coming from the user. Let's understand the final approach now. In final approach, we will have user which will send the request. Request will go to a load balancer. Load balancer will distribute the request among multiple data centers. Each data center will have a number of servers in it. We can have multiple data centers where we will have a number of servers, data center A, data center B, and each data center will also have internal load balancer which will redirect the request to the appropriate server. Even this data center will have load balancer which will redirect the request to the appropriate server. And finally, we use Twitter snowflake approach to generate fixed length sortable numeric ID, and finally that ID will be returned to the requested user. The benefit of this system is it's a multi-data center approach. Hence, even if one data center is going down, the other data centers will be there to serve the request to the user. So, Twitter snowflake approach is the best fit for our use case. Hope you have realized how starting from a single server approach, which is the simplest approach to solve our problem statement, we have gone through all the approaches and eliminated them because of one or the other issues until we reach to a specific approach which is Twitter snowflake approach, which is a best fit for our use case. Please do not forget to like this video if you have learned something new. If you haven't subscribed to my channel, please do so that you will get notifications for my upcoming videos. Thanks a lot for watching this video.